All right, guys. So remember, last week we graphed arithmetic sequences as well as geometric sequences. The arithmetic ones were linear. They look something like this. And then actually, let me redo that. Let's say this is your x and y. This is your x and y. We started off at 1. So your graph for this one looks something like this for like a linear. And then for your geometric, I know we didn't cover geometric too much, but it looks something like this. It was an exponential. Okay, so that would make sense that our formulas for our arithmetic are going to be a linear formula, so like y equals mx plus b. And then when we get into our geometric ones again, that's going to be an exponential formula. Okay, so let's say, so before we've had like sets of numbers, right? Or we just know the first number, we know the last number. When we have a sigma notation, we're only knowing the function. So sigma notation looks something like this. It looks like an E. And I always like to think of E as equal. We're going to equal all these different parts. So let's do like, and this is going to be the same as what we just covered before. We're adding all those different parts together. But instead of knowing the first term, last term, all we're knowing is where we're starting. So let's just say we're starting off at the fourth row, okay? So let's say that x is equal to 4. This is your starting point. So we're starting in row 4. And then we're going to know what row we're going to end in. So let's say we end in row 18. And let's say there's a formula for however many seats are in each row. It's different than what we've had before. And the formula is going to be 6x minus 1. So we're starting in row 4, ending in row 18, and each seat, so instead of saying, oh, there's 50 seats in each row, we can know the number of seats by the x, which is our number of rows, by using that equation right there. Okay, hopefully I didn't lose you guys yet. So you'll see a problem that would look just like this. So the bottom is where you start, the top is where you end, and then you could find the sum of everything. So you're going to use the equation that we used before. This sigma just kind of adds an extra step to it. So we need to figure out what our first term is. What is our nth term? And what is n? So first we can figure out how many terms. So whenever you're subtracting numbers, when you're counting, you always have to add an extra one, kind of like counting pages. So it's going to be 18 minus 4 plus 1. So we got the 18 from the top number. We got our 4 from the bottom. And then we're just adding 1. And that gives us 15. So n is equal to 15. Okay. And then our first term, even though we're not looking at the first row, we're technically starting at the fourth row. So we're going to figure out how many that we need in the fourth row. So it's going to be 6 times 4 minus 1. I got this equation from right here. All I did is just replace my x with 4. So that's our, technically our A1, which would be our first spot. So it's going to be 6 times 4, which is 24, minus 1 gives me 23. So our A1 equals 23. And our AN, so it's going to be our last number. So it's when our x is equal to 18. So it's going to be 6 times 18 minus 1. Once again, I got this equation from right here. I got my 18 from the top. It's our last number in the terms. I don't know 6 times 18 off the top of my head. That's going to be 108 minus 1, so we get 107. So this is exactly like we had before. Now I can just put it back in our original equation. So S of n is equal to n times the a1 plus an all over 2. Okay. And then so with that information, I'll be able to find the sum. Okay. S of n is equal to 15, 23 plus 107 divided by 2. 23 plus 107, divide that by 2, then you get 65. So S of n is equal to 15 times 65. And if I put that back in my calculator, that's going to give me 975. And so this is really good, especially when you're trying to add up something where you're not just starting off at 1, right? So for this problem, we start off at the 4th row. So this will, so this really helps us figure out where we're starting, where we're ending. For our normal equations, if we already know where we're starting, that's fine. But this kind of allows us to work for a more of a wide variety of problems. Okay, so let's take a look at a few more example problems. So let's say I have sigma notation 9, and let's say we have I instead of X. So I is our variable. Let's say we start off at 1. So 8I minus 15. So same thing as before for n is going to equal the top minus the bottom plus 1. So n is going to be 9 minus 1 plus 1. That just gives us 9. Okay. And then we're going to calculate our A1. So that's actually a first term. So number at the bottom, you're going to put in the equation. Okay. And then, so for A1, it's going to be our 1. So 8 times 1 minus 15. 8 times 1 is 8. And I think that's negative 7. Yeah, negative 7. Okay. So that's our A1. Okay. And then now our AN is going to be number at the top put into the equation. Okay. So our number at the top is a 9. So I'm going to put 9 back into that equation. So 8 times 9 minus 15. 8 times 9 is 72. Minus 15. 57 is equal to A of n. So I found all the different parts that I need. So now all I have to do is put it back in our original formula. So our original formula for finding the sum is S of n is equal to n A1 plus AN all over 2. So our n is 9. So negative 7 plus 57 over 2. I could already tell you that's going to be 50. You could double check on your calculator. So you have 50 over 2 times 9. 50 divided by 2 is 25. So 9 times 25. I don't know that off the top of my head. That gives me 225. Okay. Let's take a look at another problem. Let's do another one that's not starting off at 1. So let's say here's my sigma notation. Let's say we're starting off at, we'll do a K. We're starting off at row 5. And we're going to end off at row 14. And in order to calculate the number of seats in the row, it's going to be 10K minus 11. Okay. So same thing, n is going to equal to the top number minus bottom plus 1. So 14 minus 5 plus 1, that's going to give me 10. And then our n1 is a number on the bottom. And you put it into the formula. Okay. So I'm going to do n1 is equal to 10 times 5 minus 11. That's going to be 50 minus 11. That's going to give me 39. And it's A1. AK, because we are not doing N, we're doing the, actually, no, we'll do N, sorry. AN is going to be replacing this in here with 14. So it's going to be 10 times 14 minus 11. Ooh, wrong, too many. So it's going to be 140 minus 11. That's going to give me 129. So we're going to put it back in our original formula. So S of n, for our summation formula, is equal to n A1 plus AN over 2. So our n is 10. And then 39 plus 129 divided by 2. Times 10 gives me 840. And that would be your final answer.